This is Telemetry by the Numbers by Samuel Mullen. Give it up.
Thanks, Bruce. Is this on okay? No? Yes? There we go. I'm 46 years old. This is the first time I've ever used a microphone, so. Yeah. Yeah. So you've probably heard this quote before. What gets measured gets managed. It's a great quote. It's short, it's understandable, and it oozes common sense. For example, if we measure how much resources our systems require, we can manage the allocation of new servers. Or, if we know where our customers are getting hung up in a checkout process, we can fix the problem and improve the experience. Like I said, it's a great quote. It's just not all of it. Here's the whole thing. What gets measured gets managed, even when it's pointless to measure and manage it, and even if it harms the purpose of the organization to do so. And therein lies the rub. If we're watching the wrong data, we'll make the wrong decisions. We'll do it with the purest of intentions, and we'll do it in an effort to help our organization, but we'll still be doing it. We'll still be wasting time and human effort, resources. Who here knows what I'm talking about? Who here has monitoring set up that no one's paying attention to? Okay. Who here has monitoring set up that is recording the wrong data? So, for those of you who didn't applaud or raise your hand, I'm curious which it is. Does your organization just have it all figured out? Or do you not have monitoring set up at all? So today we're going to look at how to think about capturing metrics. And we're going to do so by looking at monitoring, what it is and why it's important. We're going to look at measurements and metrics and what we mean when we use those words. And we're going to see what makes a good metric. And of course, we're going to look at how to spot a bad one. And then finally, we're going to look at the telemetry library and telemetry metrics and get a brief summary of how to use them. So, now that I've got that covered, hi. For those of you who don't know me, which is actually most of you, my name's Samuel. I write the occasional article about Elixir, and now, well, I guess I speak at the occasional conference about Elixir. And I work here at Active Prospect. Marketing gave me about 2 pages of jargon that I was supposed to read to you, and I like most of you that I've met, so I'm going to keep this simple. This is what we do. We capture, filter, and validate sales leads. It's that simple. And we do so to document the consumer's consent to be contacted. And we do that to enable our customers to comply with government regulations, such as the TCPA, CCPA, and CASL. And really, it all boils down to helping our customers improve their conversion rates. It's all salesy and boring, but one of the other things is Active Prospect is one of the platinum sponsors. And before you ask, that's not actually how I got this speaking slot. Bruce and Maggie made that mistake all on their own. No financial incentives at all. So, I have to say this, we're hiring, so Elixir developers and DevOps people, just look for, well, I think I'm the only one wearing an Active Prospect shirt today, so they're up there on like the 5th row. All right, let's talk about monitoring. So monitoring, as I'm sure you're all aware, is really just watching the state of a computer system. And it can involve watching network traffic or CPU, memory load, errors, database performance, response time, things like that. But what we don't often think about is why we need to monitor, like the value of it. And so here's to answer this. To begin, it helps us to understand our system. You know, when we type out mix new and our application name, we understand what's going on. We understand everything that's in our little tiny application at the very beginning. But it doesn't take long until more developers have been added to the team, more features have come in and become involved. And pretty soon we have no idea what's going on inside of our application. Why is this process taking so much memory? Why is the disk running out of space? Or why are these pages running slowly? Or which pages are even running slowly? And so when we add monitoring to the system, it helps us to understand it better. The next reason is it helps us to preemptively catch issues. Because as we're monitoring, we can see where there's spikes occurs, where we're trending, we're seeing trending problems, and it allows us to catch issues, hopefully, I mean, if we're watching the right data, hopefully before our customers catch them for us. The next is because it provides benchmarks against which we can measure. And that's a strong reason to monitor to begin with. As I mentioned, it allows us to understand our system, allows us to catch those issues. We can see trends, we can see spikes. And with that benchmark, and when we see those problems and we decide that it's time to put in a new algorithm, we need to have those historical numbers so that we can determine if the new algorithms are better than the old ones. And all of this leads up to monitoring enables us to make good decisions. You have to have monitoring in place to know exactly what needs to be done, but you have to do so when you're capturing the right data. All right, so let's look at measurements and metrics. This is Devastator here, and like Devastator, metrics are made up of multiple things, in this case, measurements. A measurement is simple. It's a unit-specific value for something. It's a count. It's a duration, quantity, current value. But a measurement by itself is almost useless. It's a single point of data. It's a single point on a graph. It's data, not information. A metric, on the other hand, provides a little more context. It's used to track and assess measurements. It's summaries. It's a roll-up, ratios and rates, percentiles, distributions. This is what gives us more information, allows us to get a broader context about the data we're bringing in. But not all metrics are created equal. So what makes a good metric? Well, first of all, a good metric must be comparable. And this is probably obvious to everybody. But what's less obvious is that it has to be compared to related metric. So we've already talked about benchmarks and bringing in new algorithms and comparing with an old algorithms, and that's a great metric to compare against. On the other hand, comparing lines of code that two different developers are creating, it's a horrible way to compare. I mean, the two different developers are going to be coming from different backgrounds, different experience levels. They may be using two different programming languages. And so, well, I mean, there's a whole host of reasons why that's just a horrible idea to begin with, but, you know, staying on topic here. All right, so a good metric must be comparable. It also needs to be understandable. And this is what Alistair Kroll in the book Lean Analytics says. He says, if people can't remember the metric and discuss it, it's much harder to turn a change in the data into a change in the culture. And that's really what we're trying to get at. That's this theme that I want to talk about today, which is using data to make good decisions. You know, because every single person in here, we all understand terms like code complexity, technical debt, and refactoring. I mean, we can talk about it in the hallway, and we know what we're talking about when we're discussing it with one another. But outside of this room, with management, with HR, with sales and marketing, they don't get it. Not at the same level that we do. I mean, we can explain it and they grok it a bit, but not to the same level. But even so, of those three, code complexity, technical debt, and refactoring, only code complexity can be quantified. The other three have to be compared to some unknowable ideal. And so when we choose a metric to track, we have to choose those which can be reasoned about and understood. That's the only way, one, that we can communicate with one another and know what we're talking about, and two, that we can make good decisions. So next, a good metric is generally a ratio or a rate. And this is for a number of reasons. One, ratios are just easier to act on. So think about the ratio of speed or performance. You have distance over time. You have requests over time. And say you're trying to get to requests over 20,000 requests a second, which is what something Active Prospect is doing. We know if we're reaching that goal, whether or not we've achieved that. And so it's a ratio that's easier to act on, because if we're achieving it, then we can make that decision to go down and pursue a different feature. If we're not reaching it, then we know that we either need to expand our servers or we need to improve our algorithms. The next is ratios are inherently comparative, and we've already talked about this a little bit. But as you're tracking metrics and you're seeing these trends and these spikes, it gives you information about whether or not you need to change directions again. And this last one is really interesting because ratios are really good for comparing seemingly opposing factors. And it's easier to explain this with examples. And so the example is errors over requests. These are opposing ideas. You don't want errors coming out of your requests. I mean, that's a bad thing, right? And so you have errors over requests, and that's something that's easy to measure. Signups over deactivations. Everybody in here that's in a SaaS company knows exactly what I'm talking about. That's churn. So, and something that my fellow speakers are going to be really concerned about is jokes told by presenters versus audience laughter. So lastly, a good metric changes behavior. And that's what we're coming back to, that theme. So the metrics we have to track, one, they need to enable us to make good decisions. And they have to be aligned with your goals. Every single person in here has goals. Your team has goals. Your organization has goals. And if we go back to that original quote, what gets measured gets managed. If you are measuring the wrong data, you're making the wrong decisions. You're out of alignment with your organization. You're not following what their goals are. If you're not in alignment with your organization, you're causing friction, because that's what being out of alignment means. You're causing heat. You're causing damage. And so when we measure things, they need to be aligned with our organization's goals. So now that we know what makes a good metric, let's look at what to avoid. If you're not already familiar with the term vanity metrics, this is what Aleister Crowell says about them. He says a vanity metric might make you feel good, but they don't change how you act. For example, page views, memory usage, error counts, even orders and sales. These are all vanity metrics. And why is that? Well, let's look at this last one, sales. Let's say our site increases signups by 20%. Is that a good or a bad thing? Well, on the surface, it seems like it's a really good thing, right? But what questions does that answer? Does it explain why conversions increased? Maybe it was a marketing push or a change in the UI. Maybe it was placement in the App Store. It doesn't answer that question. What about how many customers you lost in that same period? Okay, again, churn. So what about the question, are your customers using the product that they've signed up for? Are they happy with it? And so based on sales alone, what decisions does it help you make? So by themselves, vanity metrics are easy to get excited about. They are. It's exciting to see a 20% increase in sales. It's exciting to see page views jump by 50%. It's exciting to see errors jump by 50%. Not in the way we want to be excited. So they're like junk food, right? It tastes good, but it doesn't provide any value. So now that we know about monitoring, measuring metrics, let's look at telemetry and how we can start capturing useful data. So for those of you who are not familiar with telemetry, telemetry started off as an Elixir library. It was later backported. Backported is such a horrible name. They moved it to Erlang. And they moved it to Erlang so that it could be available to the wider ecosystem. So it could be available in all the libraries and not just Elixir libraries. And this is what the docs say about it. It says, telemetry is a dynamic dispatching library for metrics and instrumentation. That's an accurate definition. This is a simplified version. Telemetry is a library which provides a simple, unified interface for capturing measurements and from monitored events. That's it. And it's really easy to add to your application. There's just 3 simple steps. The first is you're going to attach it to your telemetry. You're going to attach the telemetry supervisor. Usually you'll do it in your application.ex file, or you do it in some other supervisor. The next is you're going to handle telemetry events. You're going to do that with a function, and it's going to look for named events. It's going to match on them. and then it's going to do something intelligent with it. And then it's going to execute on the events. So inside your functions, you're going to perform a measurement, you're going to get some data, and then you're going to execute and send that data to the named event. It's that simple. Now I'm going to show you some code. Don't be afraid. And it's not so you'll remember it or you'll be able to rush out and add it to your application, but it's really just to show you the basic steps and how easy it is to add. So right here is inside of our application.ex file. And as you can see, I've added two things. One's a list of events, and the other is a function call out to telemetry. Now the events, it's just a list of lists, and I've named them web request start and success and failure. These are atoms. You can also use strings, but I'll show you an example of that later on. So we have the events that we want to capture, and these events we're going to match on with our function handler. The next step is we're going to attach these events to our telemetry supervisor. And we use, in this case, attach many because we have many events. If you had a single event, you would use the attach function. The first argument you're going to pass in is just a unique ID. I think it's to keep from conflicting with other third-party libraries that are using telemetry. So I made this one up, handler-ID. You can create whatever one you want as long as it's unique. Next argument, we're going to pass in a list of the events. We've already seen which events they are. And then the third argument is going to be our event handler, which we'll see on the next slide. The fourth argument is any extra configuration you want to pass to the event handler. So that's the first step. The second step is handling the telemetry events, and this is how simple it is. The first argument is going to be the event name, in this case, web request success. The second argument is the measurement. So when you fire off the measurement to be captured, to be handled, this is where it's going to be passed into. And so if it was a duration, you would capture it here. The third argument is going to be metadata. So any extra information. If this was a web application, it looks like it is since I'm using web request success, you might have what page it came from, where the referrer was from, maybe which user it was, if you wanted to capture that extra information. And then the final argument is that configuration, which we didn't pass on the previous slide. And then inside the function, that's where you do something intelligent with it. Maybe you send it out to the database or log it or send it to Datadog or some other third party. Maybe you send it to statsd. But this is where you would handle that data. So now we've attached the telemetry supervisor. We're handling the events as they come in, and now we just need to execute on them. Since this is a pretend imaginary web application, let's say we have an index action inside of a controller. There, you might determine who the user is, query some data, all the while determining how long each of these different actions take. And then we're going to send that, because we assume it's a success, we're going to send it to web request success. We're going to pass in time in milliseconds of 42. And then our event handler is going to be able to handle that. We're also passing the request path, so the page that was happened on, and then the status code. That's it. That's 3 steps to add telemetry to your application. Now, as I've mentioned, I made this stuff up. There's web request success, there's failure, there's stop that I made up. There's time in milliseconds. No one's going to use that. Instead, rather than making up your own event names, it's better to rely on libraries that already incorporate telemetry in. And so not only by using those do you no longer have to figure out what to name your events, but oftentimes you don't even have to execute on them inside of your functions. So plug already has telemetry built in, and so it has a list of names, and it's already measuring how long each action takes within the Phoenix application, or within plug or a Phoenix application. Ecto has telemetry baked in. You can get the time it takes for queries to run. Not only that, but in the metadata, you get the query that was generated. You even get some of the data. In plug, you get the construct. Absinthe has telemetry baked in. Even Broadway, as of 0.6, has telemetry baked in. And so you get these events for free. All you have to do is handle them. And others keep on adding it every day because, again, it's an Erlang library. So not only do all the Elixir libraries that we use and love have access to be able to install it, but so do the Erlang libraries. So now that I've shown you how to set up telemetry to handle events, your first thought might be, well, how do I organize these? I mean, it's like, I got the names, that's great, but like, how do I I do something with these measurements? You already talked about metrics, so I've got measurements. How do I get metrics? Well, Telemetry.Metrics. Look at that. The telemetry team has you covered. So this is what the docs say about Telemetry.Metrics. It's a common interface for defining metrics based on telemetry events. And I want to read that first part again. It is a common interface for defining metrics. This stumped me for a long time as I did my research. Telemetry.Metrics is just a spec. It isn't a data accumulator. It provides and it validates the different metric types that you might want to use. And it does offer some basic unit conversion for time-based measurements, but it doesn't do the aggregation for you. You know, and it makes sense. I mean, how can the telemetry team know all the different places that we're going to be pulling data from and how we're going to want to aggregate it and where we're going to send it? They can't. And so they came up with a spec, and with that spec, we can create something called Telemetry.Metrics Reporters. And, or better yet, we can use one of the reporters that's already has already been created. But let's go back and look closer at the 5 different types that Telemetry.Metrics offers. The first type is a counter, and it keeps a running count of events. Shocker. A sum, which just is going to sum up the data, the measurements that come in. Last value literally holds the last value, right? Summary, which is interesting because here you can start tracking the statistics of selected measurements. So you can get the min, the max, the average, the 95th, the 99th percentiles of data. You can get the mean, median, other statistic words that I don't know. And finally, you can get distribution, which allows you to group measurements into buckets. So if you wanted to group these into less than 10 milliseconds, less than 25 milliseconds, less than 100 milliseconds, you could do that, and then everything else gets added on to a last array. So you can group these and have distributions. All right, so let's look at reporters. Now that we've seen the spec and we know the types that we're dealing with, let's look at the reporters and how they handle the accumulation. So unlike what's great about reporters is all we have to do is really define the event names, and really it's more defining the metrics we want to capture. And then if the library isn't already taking care of it, we have to execute on them. And so what we've done is we've removed the event handler. So now we're just defining, or we're attaching and then executing. And this is an example of our application.ex file again. So instead of a list of events here, I have a list of metrics. And the first thing we're doing is we're importing Telemetry.Metrics. You don't have to import it. You can use alias or just call out the whole thing. And we have the 5 different metric types: counter, sum, last value, summary, and distribution. And here we're taking advantage of one of those third-party libraries, plug, because it has telemetry baked in. So we're using my app plug stop duration. Here it's a string instead of a list of atoms. And you'll notice with last value, summary, and distribution that I have a unit argument as well. And that allows us to convert from native time to milliseconds, so from nanoseconds to milliseconds. A lot easier to think about. And in distribution, there's a list of our buckets. So anything less than 200, less than 500, and less than 1,000, we're bucketing them and organizing it. So now that we have a list of metrics, then we just use the third-party reporter that's already, that we can download. It's Telemetry.Metrics StatsD. So we're recording StatsD information, we just provide the list of metrics. If we're using plug, plug's already sending the events. We don't have to execute on them. We don't even have to handle it. This is about all there is to it. Now you can also make your own reporters, but that's really a presentation in and of itself. But that's it. That is telemetry and Telemetry.Metrics. So what do I want you to take away from this? Well, first of all, you need to be monitoring your system. And you need to be monitoring good metrics. And what makes up a good metric again? Well, it's a metric that's comparable. It's understandable, something that we can reason about, that we can have a conversation about. It's a ratio or a rate. And it's something that changes behavior. And that's, again, what I want to talk about. Metrics, capturing metrics, managing to those metrics is about decision making. It's about making good decisions and changing behavior. And finally, use telemetry and Telemetry.Metrics. It's a great library. It's available throughout the whole ecosystem, and it's very simple to add in to any of your projects. That's all I got. So I want to thank you guys for sitting through this. Maggie and Bruce, I don't think Maggie's in here. I want to thank you not only for giving me this opportunity to speak, but really for making Lonestar Elixir possible, keeping it going. This has been an absolutely fantastic conference, and I think everybody here would agree with that. If you guys have any questions for me, you can find me online because I have a flight to catch. I can be found at SA Mullen just about anywhere or samuelmullen.com. Thanks again. You guys have been great.